Source reconstruction is basically about answering the question, where in the brain is the origin or the generator site of the activity that we see at the scalp? And Curry has a number of ways of addressing that question, and I'll show you just a few of them now. So starting off, this is a single epileptic spike, which I'll display as a butterfly plot, which superimposes the channels together. And I've set a time range around the spike because the question here is we want to know where the origin of the epileptic activity is. And so we're interested mainly in the earliest part of the spike itself. Here we've got a 2D map, and if we change the time point that we're looking at, we see the map change accordingly. And so now we want to do source reconstruction. I want to make sure I've got the right interval for noise estimation. So I'm going to change it slightly. Otherwise it was going to include a little bit of the spike in with the noise. Now, the next thing we would do, if we wanted to do source reconstruction, we'd have to select a head model to use. Curry comes with 1, 2, 3, or 4 spherical shell models. It has pre-computed models based on the MNI average database. But what we want to do, and what one of the real strengths of Curry is that you can create a head model using the MRI data from the same subject. This will give you a much more accurate representation. So let's go to here, and we'll create a BEM model, a boundary element method model. So I'll start that, and you'll see down here it's going through the automated process, and what it's doing is creating a head model with 3 compartments. There's a skin model, or outer skull, and inner skull compartments, and those 3 together will create the head model or the BEM model. It's also segmenting the skin, so they'll have a representation of the outer skin, and it's also segmenting the cortex. And this will take a few moments to finish, and I'll come back when it's done. And so now the BEM model is completed, and if we look over in this list, we'll see the BEM skin, outer and inner skull. These are the 3 compartments that comprise the BEM model, and we've also segmented the skin and the cortex, which I'll just display. And we'll take a look at it from the left side, and you can see what the segmented skin and segmented cortex look like. Okay, now let me take the skin off and the electrodes off, and we're ready to continue with source reconstruction. So let's go back to the head model, and let's select the BEM model that we just created. And now we decide which type of dipole, or which type of source reconstruction method to use. We can do a number of different types of dipole fits, and these are single equivalent dipoles. And based on previous research that's been done with epileptic cases, a moving dipole is very effective. What a moving dipole does is create the dipole solution for each time point within the time range, and then plot that out as separate dipoles. And this will take just a few minutes or a few moments to complete. And now we have the dipole results displayed on the cortex. If I increase the transparency of the cortex, it will make the deeper ones easier to see. And I'm going to change the clip below threshold just so we can see the results that best represent or that best explain the data. So now we're seeing a dipole for each time point. I can change this so we can see them individually, and now as we step through the time range, you can see the dipole move. Let's go back to one of the first ones. So we have in fact, let me go to a larger view, you can see better. So we have a dipole here. This ellipse is a confidence ellipsoid, and what that means is we're 95% certain that the solution is somewhere within this sphere, and the most likely spot is at the center of it. And as we move in time, you can see that the confidence ellipsoid is going to get smaller, and this looks like a pretty good solution right here. And let's go back to the full display, and we're 10 milliseconds, or at 10 milliseconds, which is, it's about 2/3 of the way into the spike. And if you want to, we can play a movie and just see the evolution of the whole thing. Let me play it again. And you can see how it moves around. All right, so this is one type of a solution. And this is saying basically, for a given time point, find me the point somewhere within the head that best explains the data that I'm looking at from the scalp. Okay, now let's use a different method. This will be current density. Before I do that, I'm going to tell it to constrain the results just to the cortical surface. Rather than results being anywhere within the volume, we're going to constrain it just to the cortical surface on the basis that the vast majority of epileptic spikes are probably cortical in origin. So now let's go to current density, and there are a number of different models to use. In this case, I'm going to take S. Loretta because it's fairly accurate, it's very accurate, and it's also fairly fast. Some of the other ones will take quite a while, so we'll do a relatively quick one, and it's also fairly accurate. What this is doing, it's assuming that instead of a single dipole source, there can be multiple dipole sources. Potential sources are distributed all about the segmented cortex, and there are thousands of potential sources. What I'm going to do now is select the ones that best represent the activity that we're seeing. And we can see that there's pretty good agreement. Let me just change from time point to time point, and you can see there's pretty good agreement between two very different mathematical approaches. So two different approaches are giving very similar results. I'm going to remove the results down here, and let's take a look at the image data in more detail, and we can see on the subject's MRI data exactly where the CDR results are. Okay, let's go back to all the views, and actually I'll go to the 3D view. So now we've got the results, and if we want to make the display a little bit more interesting, can add the skin to it, and I'm going to take off the transparency completely and instead cut away the part that will expose the results. So I'll go to the cut plane, we'll do a triple cut, and now we've cut away the section of the scalp and the skull, and we've gone down to the cortex, and we can see where the results are. So it's just a different way of displaying the findings. So that gives you a brief indication of what Curry can do with source reconstruction. There are many more options and other things that I can't show you without spending a great deal of time doing it, but this gives you the basic idea of source reconstruction in Curry 7.